Hello everyone, in this lecture we will discuss about heating of a liquid methanol. So we will use a heater to heat a liquid methanol. Liquid methanol at 25 degrees centigrade is heated and vaporized for use in chemical reaction. How much heat is required to heat and vaporize 2 kilomole per hour of methanol at to 600 degrees centigrade? So in order to heat the methanol from 25 degrees centigrade to 600 degrees centigrade, how much heat will be required? So this is a liquid methanol at 25 degrees centigrade. We will use Aspen HYSYS and we will calculate the heater duty in order to heat methanol from 25 degree to 600 degree centigrade. So we will go to Aspen HYSYS. This is the component list. Click on add, and we have one component which is methanol. Yes, okay. Now come to the fluid package and click on add. So for this we will use the Finn-Robinson, which is used for the hydrocarbon. So I'm using the Finn-Robinson equation of state. So I'm using the Finn-Robinson equation of state. Finn-Robinson. So it is okay. Now go to the simulation, and here we will use the heater. This is a heater. So click on the heater and close this one. Double click on the heater, and this is the heater inlet. So this is the heater in, and this is the heater outlet. So the heater inlet and the heater outlet. So now we will go to the worksheet, and we have a liquid methanol. So we have liquid methanol in the question. Liquid methanol at 25 degree is heated and vaporized for use in chemical reaction. 25 degree, the liquid methanol temperature is 25 degrees centigrade, and it is a liquid methanol, so the vapor will be 0. It is liquid, okay. And we will go to the composition. It is pure methanol, so it is methanol mole fraction will be 1, okay. So this is the, go to the condition, the liquid methanol. So now the pressure is calculated by the Aspen HYSYS. So the pressure of the liquid methanol is at 25 degrees centigrade. The pressure of methanol is 0.14 bar. So now this is okay. Now go to the and how much heat is required to heat and vaporize 2 kilogram mole per hour of methanol. So the molar flow rate of methanol is given to us 2 kilogram mole per hour. So 2 kilogram mole per hour. 2 kilogram mole per hour. This is 2 kilogram mole per hour. Yes, okay. 2 kilogram mole per hour. This is the molar flow rate of methanol which is given to us. Now this is okay. Now it shows in the question and methanol is heated to 600 degrees centigrade. So the outlet temperature is 600 degrees centigrade. 600 degrees centigrade, and it is in the vapor phase. So now it is in the vapor phase, so it is okay. Now it shows that require energy stream. So go to the design, and here we will go energy. So it shows the unknown delta P. Go to the parameter, and the delta P is, suppose there is no pressure drop in the heater. So it is okay. Now it is okay. Now go to the worksheet, and how much heat. So go to the design, and this is the delta T, and this is the duty of the, this is the duty 156147 kilojoule per hour. This is the duty of the heater. This is the duty of the heater. Now this is the duty of the heater, and this is the heat flow. So this is the property. You can check the property rating. So the diameter, the inlet outlet, the designing. So this is the duty of the heater. So Aspen HYSYS calculate the duty of the heater. Now if I'm changing the this is the connection. So this is the rating. I'm going to the worksheet and go to the condition, and here the pressure is this one. Now I am close this one. This is the heater, so this is okay. Okay, now this is the heater inlet. So the heater inlet, I'm changing the heater inlet. uh, Temperature is 25 and this is okay. I'm changing this one. Now the heater, I'm changing this one to 250 kilopascal. 250 kilopascal. And now go to the, close this one and double click on the heater, and now go to the duty. How much duty of the heater will be required? So this amount of duty of this amount heater duty will be required. So this was all about the heater. Thank you very much for your attention. If you are new to the channel, please like and subscribe.